I am Alfredo Sanz, head of the technology of smart energy on Microchip. I worked on PLC for around 20 years ago, and I will introduce the Microchip G3-Hybrid. In the past 2 years, starting early in past year, G3 Alliance was start the process to evolve from PLC technology to a G3 technology, combining radio and PLC for smart grid and IoT application. And then on this process, the idea is to provide in a single network both wired and wireless device connected. On the selection of the technology, G3 Alliance was selected radio interface based on 50.4G. Basically the same technology on the PHY and on the Mac used by the Wi-San Alliance, Wi-San FSK PHY. And it's working? Okay. And also OEDM5 supported also for Microchip that enable also 4 times more robust communication in urban environment. For PLC interface, Microchip Hybrid was the first implementation certified for G3 Alliance on Hybrid. The Hybrid advantage of that is to assure that in complex environment we can assure full coverage for communication. Hybrid communication, hybrid technology could be deployed in combination with traditional PLC-only device and RF-only device aiming system. The key factor to consider is the installation cost, operational maintenance cost, cost of communication modem, total meter cost, cost of communication network. Then in optimal deployment plan can be deployment based on each scenario achieved for minimum cost, considering thickly the requirement, regional characteristic. The combination of hybrid standard technology combining PLC only and RF only can reduce the total system cost by means of the reduction of the amount of the DCU needed to communication, and also increase the amount of smart meter that could be managed in each DCU, because we extend the coverage of the technology. Consequently, we reduce the installation cost, operation and maintenance cost. This is key aspect to consider for the utility. On Microchip, we was working in 2 areas for the last year. One is working on the simulation. Microchip have a PLC simulator to assure the performance of the network before the deployment based on PLC, and with the evolution of G3 from PLC to hybrid system, we was also evolve the hybrid simulator. For that, we need also an accurate model of the radio frequency PHY model, and then we was make measurement on the field for this medium, because RF implementations and FSK is quite young, quite early deployed, and then we need to be sure that what is the performance to include also in the simulator. Then we was make that, and we was presented that some week ago on ISPLC conference and in international conference on smart grid communication. Okay, first about the simulator. Simulator of a Microchip can run different instances, could be 100, 300, 1,000 instances on a network of the Microchip hybrid communication software. Each of the instances run the software of a node. This is the final code that at the end will run in a real device. We use real C++ code, then we can use the simulator to assure the performance and also to debug the system a real system. One of the problems we find to debug this kind of system years ago is that in some cases it's necessary to debug not only the device isolated, but also the device connected in a mesh network. And then for that we can simulate real code, we can run in critical condition, controlled condition, and when we identify a problem, then we can stop the network, we can debug line by line in any of the meter, we can see the variable, and after that we can replace the simulator in the same point and no problem with that. Then we can stop all the full network, and also we can debug in one of the meter on any other meter, and then we can restore all the network. This is not possible to do in real environment. Okay, this is very convenient, but we need also to have the full model of not only PLC that historically we have for measurement of the field, but also in RF. And we was make this model based on field measurement that we was made in the past year. Using this simulator, we was make simulation of a very complex infrastructure. We was simulate 300 devices, first in a PLC only scenario to validate the connectivity in a regular case. After that, we make a second scenario where we increase the noise with the same position of the node. We increase the level of the noise around the head of the network. This is the red area in the center. And then with this, we assure that in normal condition, a PLC-only network cannot work in this scenario. But in a hybrid system, the hybrid can switch to the RF medium, and then they can work properly. Okay? And we can assure the functionality and the connectivity of the full network. We can assure the full 100% case of the connectivity. And in a second case, we was tested the same amount of 300 meters, but 50% hybrid and 50% RF only. And with that, this could be the case, by example, of a network combining electrical meter and gas and water meter. And then that we try to test on that is that we can integrate other applications in a PLC-only network. Okay? This is the second case. The red connection are the RF connection, the blue link are the PLC link. And in both of the cases, we had 100% of connectivity. We was to analyze the performance of the system, we was include some key performance parameter. One is the coverage. In all the cases, we have 100% of coverage. We was include also the network ramp up, the time to achieve 95% of the node connected. You can see that the PNC only, by example, we have around 20 minutes to connect all the network. In a very more difficult network, in the second case, with a hybrid network with a lot of noise in the center, that with only PLC is not possible to cover, we achieve full connectivity in around 1 hour. Okay? And in the third case, again, with the similar level of noise, we have similar time to connect. We move to 20 minutes to 29 minutes for connect all the device, but in this case, 150 meters with PLC and 150 meters with RF. Okay? For test that, we was make also the thickening, not only the bootstrap ramp up time, but also we was stress the network with real DLMS traffic. We was make thickening traffic, and we was simulate the time to thickening the 300 meters. We can see that in average, the time to thickening 300 meters in DLMS with PLC only is around 16 seconds, and 16 seconds for each meter. And in the case of hybrid networks, it's around 70, and in the case of 50% hybrid and 50% RF only, we have around 20 seconds by meter. Then it's very effective in every case. We still, with the connectivity, the ramp up is very similar, and we assure the very efficient communication similar that we have with PLC only. Also, we was work in the model of the RF channel as a function of the frame error rate versus the distance. In the theory, you know that in the free space communication, the model could be the orange line. We was make tests in 4 different scenarios, 4 different locations, moving from very dense urban area to a spread urban area. And we was make the measurement of the distance and the baud rate, and with that we was develop a model of frame error rate versus the distance. You can find the article on the ISPLC in the reference. And then we can see that for the same distance, we have one increase around 10% of the frame error rate. This is around 8 dB. But in the same frame error rate, for example, around 60% of the frame error rate, then we have one coverage moving for the same baud rate for 50 kilobit. We have from 75 meter to around 150 meters. This is double distance with the same baud rate using OFDM technology. And this is in the more complex topology that is urban area. Typically, where you have the meter underground in the meter room, and then you need to assure the coverage. And with this technology, you can assure 100% of coverage, and you have similar coverage on RF that in PLC. For that, in Microchip, we provide field-proven technology both for PLC and for RF. On PLC, we have more than 10 million of modem installed, covering in a single device, multi-protocol, Prime and G3, and also with the best class efficiency on the transmission, because we use Class D power amplifier on the transmission. And with that, we have avoid the problem of heating in the device in some areas in the world, in the Middle East, in Arabia Saudi, and similar. There are problems of temperature, and then with that, there are no problem because the device is full cool. They don't have problem of heating. We provide a full solution covering from only the transceiver with the driver, the evaluation kit, and different kind of microcontroller to use with that. And similarly to that, on the radio, we have more than 80 million of modem deployed with this technology, covering all the 50.4 band in the world. In the case of the Sud-Giga, we use the transceiver 215 that cover FSK, OFDM, and OQPSK, and also support OFDM solution with the 4 times eager robustness that the urban environment versus the FSK. Then it's a proven solution, it's a ready solution, and in the case of G3, it's a certified solution, both PLC and RF. Thank you very much. You can have the contact for any question.